Hello, this is section 3.3 measures of the position. For the measures of the position, we need to learn about the z-score, and which is we can call the standard score. So z-score or standard score is a value of is obtained by the subtracting the mean from the value and divide by the standard deviation. So this is a formulas you can use. So the symbol for the standard score is a z. The formula is that, and then for the sample mean, we have to use x bar for standard deviation as s, and then for the population, we are using mu as a mean and divide by sigma, which is the standard population standard deviation. So the z-score represents the number of the standard deviation that a data value falls above or below the mean. So if the z-score is positive, the score is above the mean. If the score is 0, the score is the same as the mean. And if the z-score is a negative, and the score is below the mean. Okay, so because when we using the mean and the standard deviation in the normal distribution, so this is what it was. Okay, so in the middle was a mean, and then the first place is gonna be the first one standard deviation, and the one step right is gonna be the two standard deviation place, and then this is gonna be the three standard deviation place. On the left, you got a x bar minus 1 standard deviation place, x bar minus 2s for the 2 standard deviation place, and the x bar minus 3s. But instead, now what we're going to do is we're going to use the x bar as a 0, as a mean, and then this we call the 1 and 2 and 3, and this is the place of -1, and then -2 and -3. Then what happened is, from the one standard deviation from here to here, right, it's about 68%. And then from the two standard deviation, it's about 95%. And then the three standard deviation is about 99.7%. Okay, so that's what, yeah, so we're just using the z-score instead of the one standard deviation or two standard and three standard deviation. Okay, so let's look at the example one. So a student scores 85 on an English test, while the mean score of the student was 76, and the standard deviation was 4. She also scores 42 on French test, where the class mean was 36 and standard deviation was 3. Compare the relative positions on the two tests. So for the English, right? English, her score was the 85. Her score is 85. And then the mean for that English test was 76. And then the standard deviation is 4. So in order to find the z-score for English, right, which is x minus x bar over s. So x is actually the value from the her. So 85 minus 76 over 4, which is it's about 2.25. And for the French, her score is 42, and the mean is 36, and the standard deviation is 3. So z-score is x minus x bar over s. So x is 42, subtract 36 over 3. It comes as a 2.00. So in here, as you notice, the z-score for the English test is higher than the z-score for the French test, right? So z-score 2.25 is higher than 2.00, right? So because of that, her relative position in the English class is higher than her relative position in French. So which means she's doing better job in English than the French. Okay, all right. So let's go to the next problem. So in number 2, a recent study mean age at which men get married is said to be 26.4 years with a standard deviation of the 2. The mean age at which women marry is 23.5 years with a standard deviation of 22.3 years. Find the relative positions for a man who marries at age 24 and at age who marries at 22. So there's a man and the woman. So as a man, the age is the 24 years old, but the mean is 26.4, and then standard deviation is 2. So z-score, which is x minus x bar over s, it's going to be 24 minus 26.4 over 2, and then it's about negative 1.2. For the woman, age is 22, and the x bar is 23.5, and standard deviation is 2.3. So for the z-score, x is 22, subtract 23.5 over s 2.3, and then it comes out as a negative 0.65. So this time is actually the negative 0.65 is greater than negative 1.2, so which means the woman's age at marriage is relatively higher than the man's age at marriage. Okay, right. So, alright, so that's how you figure out the z-score, okay? And then I'm going to talk about percentile. Percentiles divide the data set into the 100 equal groups. So there are 100 equal groups here, 100 equal groups, okay? So percentile are symbolized by the P1, P2 up to P299 and divide the distribution into the 100 groups. So which means if you have data which is from the smallest value to the largest the data value. So there's a P1, P2, and P3, and then all the way to P98 and P99, which means each interval will give you the 1% of each. So overall, it gives you the 100%. Okay. So what is the percentile formula? The formula for the percentile divides the data set into the 100 groups. So the percentile is the value for which about the p% of the data value are less than, or for less about 10 minus 100 minus p% of the data values are large than. So this is the formula. Percentile is number of the value below the value that given plus 0.5 over total number of the value from the data set, which is n, and then multiply by and then multiply by divide and then multiply by 100. Okay, all right, so let's take care of this one. So example 3, the number of the traffic violations recorded by a police department for a 10-day period is shown as 22, 19, 25, 24, 18, 15, 9, 12, 16, and 20. So first of all, if you want to find the percentile, we have to write the smallest data to the largest data. So the order that could be starting from the 9. So it's a 9 is the smallest, and then 12, and then 15, and then 16, and then 18, and then 19, and then 20, and then 22, and then 24, and 25. Okay, all right, so you need to put down the number in the ascending order, and then we're going to find the percentile. All right, so now you need to find the position of the 16. So 16 is, I think it's kind of too big, so about this much. Okay, so you need to find the 16 because we are looking for the percentile rank of 16. So we are looking for 16, right? So 16 is right here. So what you need is, you need to find the number, the value below that number. So how many numbers below the 16? So there's a 1, 2, 3. So there are 3 numbers. And plus 0.5. And then divide by total number of the 10. And then multiply by 100. And then you got the 35th percentile. Okay? Which means the value of 16 is higher than and 35% of the data value, which means up to here. So from up to here is 35%, and then from here to here is going to be the 65%. So she belongs to the top 65%. The 16 belongs to, okay? And so find the percentile rank of 24. So we have order number. So we need to find out where is a 24. So 24 is, let me write down again. So next number is 9 and 12 from the same order number. And then we are looking for the percentile rank of the 24. So we are looking for, where's the 24? So for the percentile, so how many numbers below the 24? There is 1, 2, 3, 4, 5, 6, 7, 8. So there are 8 numbers. And plus 0.5 over 10 numbers and multiply by 100. So it's going to be 85th place, right? And percentile. So which means the data value of the 24 is higher than 85% of the value in the data set. Okay, so now we're looking for the finding the data value using the percentile. So finding a data value corresponding to the given percentile. So step one, arrange the data in order. Arrange data in order from the lowest to the highest. And then we substitute into the formula, which is n is the number of the data value and the percentile, and divide by 100. Give us the C, and then we need to think about 2 different C. If the C is not going to be a whole number, we always rounding up. We rounding up to the next whole number. And then if you have a C is a whole number, and then we need to find the C number you sit place, and then the next number, and then to find the half away. So you just need to add them up, these 2, add them up and divide by 2. Alright, so let's take a look. So find the value of the corresponding to the 65th percentile. So what data value is in the 65th place? So from I'm using the same data value, okay? So from the 9, 12, 15, 16, 18, 19, 20, 22, and 24, and 25, right? So what I do is C equal to n times P over 100. So there are 10 numbers and percentile is 65, and then over 100. So it gives you the 6.5. Now it's a decimal, not a whole number. Now you have to go to the next whole number, which is 7th place. So what number is in the 7th place, which is 1st, 2nd, 3rd, 4th, 5th, 6th, and 7th, so which is 20. So numbers are 20. So 20 is 7th place, and then therefore the value of the 20 corresponds to the 65th place percentile. Alright, D. Find the data value corresponding to the 30th percentile. So from the 9, 12, and 15, 16, 18, 19, 20, 22, and 24, 25. Okay, so I want to looking for the what value is in the 30th place. Okay, so C equal to N times P over 100. So N is 10 values and percentile is 30 over 100. So it gives us 3. So since the C is 3, which is a whole number, now you have to take care of you have to use the 3rd place and the 4th place number. So 3rd place means you got 1st, 2nd, 3rd, which is 15, and next number 16. So you have to use the 15 and 16 and divide by 2, which is a 15.5. So which means the 15.5 corresponds to the 30th percentile. Okay, now I'm going to talk about quartile. The quartiles are the distribution into 4 equal groups and denoted by the Q1, Q2, and Q3. So, which means if you have a horizontal line, and then first place is smallest value from the data, and then the largest data value, and then we divide this group as a 4. Okay, so first one is we call Q1, Q2, and Q3, but the Q2 is exactly same as a median. And then each group actually has 25%. So find the data values corresponding to the Q1, 2, and 3. Arrange the data value. So same idea, arrange the data value, always the lowest to highest, and then find the median for the Q2, and then for the Q1 it's gonna be the value that the falls below Q2, which is we call Q1, and the median for the value that is falls above the Q2, we call the Q3. All right, so let's find it. So find the Q1, Q2, and Q3 from the data value here. So this is already the ascending order, so that's a good thing, right? So since we need to find the Q2 first, okay? So Q2 is, which is a median. So find a median means there are 10 numbers, right? And then divide by 2, which is a 5, okay? Because that means that when you have even numbers, you will get the 2 middle number. So you get the 5th place and then the 6th place. So 5th place number is 1, 2, 3, 4, 5, 18, and 19. So use 18 and 19 and divide by 2, which is 18.5 is a Q2. Now, since there are 10 numbers, then you can divide these 10 numbers exactly the half, which is you can divide from here. So if you use divided from the 8 and 8, 9, 19, and then you get the 5 number on the left, and then you got the 5 number on the right. And then you'll find the median from the first 5, and then you want to find the median from the second 5. Since there are 5 numbers, so median is going to be right in the middle, right? So which is the median, which is a Q1, is going to be the 15 because the 15 is the middle number of the lower half. Okay, and then 22 is the middle number, the upper half. Okay, so Q3 is 22. So there's two numbers. Okay. All right, so not bad to find it. Okay, now interquartile IQR range. Interquartile range IQR is the difference between the third and fourth quartile. So this is the formula. Okay. All right, so find the interquartile range of the data set, which is we are using the same thing, right? So Q2 was 18.5, right? From the previous problem, I'm using this information, okay? Because it's the same data values. And then Q1 is 15, and then Q3 was 22, isn't it? So in order to find the interquartile range, you're going to subtract from 22 minus 15, which is going to be a 7. All right, deciles. Decile divides distribution into the 100 groups, making 100 groups, okay? So from the lowest value to the largest value, smallest, the largest, and then you divide the 10, okay? So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's going to be the D1, D2, D3, D4, D5, D6, D7, D8, and D9. And then each interval give you the 10%. So 10% of the each. So percentile gives us a 1% of the interval. Quartile give you the 25% of the interval. And then decile give you the 10% of the interval. All right, so outlier. The outlier is extreme high or extremely low data value from the data set. So procedures to identifying the outlier is you need to write the number in the order to find the Q1 and Q3 because that give you the IQR. And then IQR you gotta multiply by 15 on 1.5. And then we subtract the value obtained at step 3 from the Q1 for the lower outlier. And then the upper outlier, we adding the value step 3 to the Q3. So what you mean is this is actually the giving you the boundaries, okay? So this is actually we call the lower fence. And this one we call the upper fence. So once you find the fence and then any data value more than upper fence, that's outlier. Any value is lower than the lower fence, that will be the outlier too. All right, so let's take a look. Check the following data set for the outlier. So this is a different data value, okay? So what I do is you need to find the Q2 first, okay? So there are 1, 2, 3, 4, 5, 6, 7, 8. So which means there will be a 2 middle number, right? So middle number 8 divided by 4. I'm gonna say 8 divided by 2. 8 divided by 2 is a 4, which means the first place and the fifth place number. So first place number is gonna be first, second, third, fourth, and fifth, right? So it's gonna be the 13. So 13 and 15 and divided by 2. So you get the 28 over 2, which is a 14. Now from the Q1 is actually the divide this sets as exactly the half. So right here. So now you have the 4 numbers on the bottom and then the 4 numbers on the top too, right? So you get the 2 middle numbers. So middle number for the Q1 is 6 and 12. So 6 plus 12 and divided by 2, which is a 9. And Q3 is the upper, so 18 plus 22 divided by 2, which is 20. So now what you do is I need you to find the IQR, which is Q3 subtract Q1 which is 20 subtract 9, gonna be 11. And then we're gonna find the lower fence, which is gonna be the Q1 subtract 1.5 times IQR, which is Q1 is 9 minus 1.5 times 11, which give us a negative 7.5. And for the upper fence, it'll be the Q3 plus 1.5 times IQR. So Q3 is 20 plus 1.5 times 11. And then you'll get to the 36.5. So now go back to the data value. Is there any number lower than the negative 7.5? No. Is there any number is more than the 36.5? Yes, which is a 50, isn't it? So we can say the value 50 is outlier, because it's not between the negative 7.5 and 6.5. Alright, this is all for the 3.3. Thank you for listening.